Hi, welcome to this Blender video tutorial entitled WaveModifier. Blender's WaveModifier is a deformation modifier that creates an animated wave-like motion along a mesh. To demonstrate Blender's WaveModifier, I've placed a flat plane object in my Blender scene. I'll tab into Edit mode. Blender's WaveModifier, like all of Blender's deformation modifiers, requires a certain amount of vertex density in the base object to facilitate the influence the WaveModifier will have on the underlying mesh. For this reason, I have subdivided the plane object a number of times, creating a vertex-dense mesh. I'll tab out of Edit mode. With the plane object selected, I'll click on the modifier icon in the Properties editor and add a new modifier. I'll select the Wave Modifier. As you can see, the mesh is immediately affected by the Wave Modifier, creating a belly button rise in the center of the mesh. The Wave Modifier is automatically associated with the Blender animation timeline. I'll decrease the length of the default animation from 250 to 100 frames. And then I'll press the Go button and play the animation. The default wave modifier settings produce a quick wave motion, starting in the center of the mesh and flowing out to the sides. Note that the deformation of the vertices is in the Z direction. By default, the X and Y checkboxes are selected. This propagates the wave motion from the center of the XY plane to the outside edges. I will uncheck the X checkbox. This causes the wave motion to be constrained to the Y direction. Unchecking the Y checkbox as well causes the mesh to simply move up and down in the Z direction. I will checkmark the X checkbox to set the wave motion along the X-axis. Unchecking the cyclic checkbox limits the wave action to one pulse, starting at frame 1 of the animation. I will recheck the cyclic checkbox. Checkmarking the Normals checkbox will cause the wave action to displace vertices along the surface normals rather than the Z-axis. With our plane object, the surface normals run along the Z-axis, so there's no difference. This setting is usually used when the wave modifier is applied to more dimensional objects. To demonstrate this, I'll stop the animation and go to Layer 3. Here I have a cube, sphere, tube, and torus objects. All of these objects have been subdivided to form vertex-dense meshes. I will add a wave modifier to the cube and checkmark Normals and limit the wave motion to the X-Y direction and play the animation. I will add a wave modifier to the sphere and checkmark the Normals and limit the wave motion to the Y direction. I will add a wave modifier to the tube and checkmark Normals and limit the wave motion to the X direction. Finally, I will add a wave modifier to the torus and checkmark Normals and limit the wave motion to the Z direction. I'll stop the animation. I've discovered that in this beta version of Blender 2.5 that some of the wave settings become irredeemably corrupted when there are multiple wave modifiers running on multiple layers. For this reason, I'll reset this Blender file. And I'll re-add a new wave modifier to the plane object. And I'll set the wave motion to the X direction. And play the animation. Near the bottom of the Wave Modifier panel, there are 4 major wave controls. The speed setting controls the speed of the ripple and can change in value from -1 to +1. I'll lower the speed control to 0.05. The 3 remaining controls work together to develop the character of the wave. The height setting controls the height of the ripple and can range in value from -2 to +2. The higher the value, the higher the wave. The width setting controls the distance between the crests of succeeding waves and can range in value from 0 to 5. Generally, the lower the value, the more waves that can be propagated over the animation timeline given the speed setting. The narrowness setting controls the width of the amplitude of the wave, and it can range in value from 0 to 10. The higher the value, the narrower the pulse of the wave. For a nice sine-shaped wave, set the narrowness to twice the level of the width. I'll set the height to 0.3 and the width to 2.25 and the narrowness to 4.5. Notice that the wave appears to propagate from left to right and then again from center to right. This is because the wave actually starts in the center of the mesh and propagates, in this case, toward the positive x direction, and then picks up at the other end of the mesh and follows through along the positive x direction. As the Blender animation loop switches from frame 100 to frame 1, the wave starts again in the middle. To make this clearer, I'll stop the animation and go to frame 1. Note that the wave is in the center, already formed. As I drag the timeline through the animation, the wave runs to the positive end of the mesh and then, given the width setting, picks up on the negative end of the mesh and runs through to frame 100. Now I can solve this problem by offsetting the start of the animation by adjusting the offset timer control. I'll set the offset time to a positive 40. This means that the animation will start on frame 1 as if it were on frame 40, given the control settings. I'll play the animation. The animation is in fairly good sync, as the start and end of the animation occur when the mesh is flat. The overall length of the WaveModifier animation, not to be confused with the length of the Blender animation, is controlled by a combination of the offset, life, and damp time controllers. The life setting controls the length of time the wave propagates. A setting of 0 means forever. And the damp time setting controls the decay of the final wave to flatness after the wave's life. I'll set the offset to 30 and the life to 10 and the damp time to 50. I'll set the speed to 0.03 and the width to 1.5 and the narrowness to 3. This combination of settings, given the size of the mesh, creates a nice gentle wave that softly fades out over 90 frames. An alternative to setting the time offset is to reposition the start. This is controlled by the position X and position Y controllers. I'll stop the animation and go to frame 1. I'll set the X position control to -1. This sets the starting position of the wave at the left end of the mesh. I will checkmark the Y direction motion checkbox so you can see this more clearly, and play the animation. I will change the offset time to 0 and the life to 30. I'll set the Y position to -1. I will uncheck the Y motion checkbox so that the wave modifier runs strictly along the X-axis. The fall-off controller adds a bit of a dampening fall-off ripple at the end of the wave motion. I'll set the fall-off to 1. The start position box allows for the starting position to be set by another object. This is useful sometimes, as the other object can be animated, and thus the starting position can be animated. The vertex group control allows the wave modifier to influence a particular group of vertices. I'll stop the animation and click on the texture button in the properties editor and add a new texture to the scene. I'll use the default procedural clouds texture and name this texture Water. I'll set the noise size to 0.5, and I'll select Hard Noise. And then I'll go back to the Plane Objects WaveModifier panel. I'll set the fall-off to 0 and the height to 0.75. I'll click in the texture box and select the water texture, and then play the animation. Notice that the water texture dynamically displaces the mesh along with the wave displacement.